In this video, we're going to take a look at how to use manipulatives to represent decimals. Now, this is where it's positives and negatives, and here's what I mean. That set of blocks that you have with the giant cube and the flats and the longs and the little units are just pieces of plastic, right? There's no inherent value attached to any of them unless we assign it a value. And up to this point, we've always assigned the little cubes as units, and then the long rods as tens, and then the flats as 100, and the cube is 1,000. But they all go up by powers of 10, right? You get 10 little cubes, you make a rod. 10 rods, you make a flat, and so forth. Can we assign them other values? What if instead of assigning the value of 1 to that little cube, what if we assign the value of 1 to the rod? Okay. Now, if that rod is worth 1, then that little thing must be worth 1/10 of it. And so now I've got the rod worth 1, the little block worth 1/10. If I get 10 ones together, now that flat is worth 10. And so now that gives me an opportunity to illustrate other numbers that are decimals, not just whole numbers. So if I had 3 and 2/10, I could illustrate that by having 3 and then 2/10. So, on the positive side, I have a way to illustrate decimals like 3 and 2/10. The downside, though, is it can become confusing sometimes because we have to make sure that we're accurate in naming the smallest value first before we move on to the next problem. Because here, I'm assigning different values to those little blocks depending on the problems. So if I had 32, I would call it 3 tens and 2 units. If I have 3 and 2/10, now I have 3 units and 2/10, and now the blocks mean different things, and for some students that can be confusing. The nice thing, though, is this illustrates that working with decimals is the same thing as working with whole numbers because they're all in base 10. So the first thing we'll do is look at different ways to represent them. So let's say I had to represent 5 and 4/10. First thing I would do is I would define the smallest block. So instead of letting the little block be worth 1 unit, I'm going to let that be worth 1/10. How did I decide on that? The 10th is the smallest value that I have in the problem. I have 5 holes, I've got 4/10, so let the smallest block represent tenths. So if the smallest block represents tenths, then 10 of those represents a unit, which is the rod. So the rod is worth 1, the little unit block is worth 1/10. Sometimes you'll hear me say, define the unit, or define the smallest block. Define the smallest block means tell me what that little block means. In this problem, it's worth 1/10. So if I have 54 of them, I have 54 tenths. I have 5 holes and 4/10. But what if I had a number like this, 5 and 42 hundredths? Well, now that little block can't be worth tenths anymore, because then what am I going to do with the 2? So now I got to make that little block worth 1/100th. And that's what this picture illustrates. If I let that little block be worth 1/100th, then 10 of those hundredths makes a tenth, and 10 of those tenths makes a unit. Okay? So if I had 1 and 23 hundredths, I can illustrate that with 1 flat, 2 longs, and 3 little unit blocks. So now I have 1 unit, 2 tenths, and 3 hundredths, 1 and 23 hundredths. What's another option? Well, what if I had 3 decimal places? What if I had, let's be creative here, 1.234. So 1 and 234 thousandths. Well, now how does that work? Thousandths, hundredths, tenths, and then this is the cube. All right. So look at 2 and 235 thousandths. The little tiny blocks are your thousandths. These are your hundredths. These are your tenths. And these are your holes, or your units. And that's almost where the game stops because we run out of blocks. So there is one other option. You'll actually see this in the homework. You'll sometimes see like little slivers of blocks. as tenths of those little tiny blocks. So I don't know, you're ever familiar with bingo chips, those little things that are you can sort of see through? Well, if you or little algebra tiles, I guess is another representation. So sometimes you'll see like slices of blocks, like flat slices of blocks, as one more way to make a tenth of those little things. But then you really do run out of the ability to illustrate these things after a while. So on the other side of this, you don't have anything bigger than those blocks, so you don't have any tens and you don't have any hundreds. So it's the same thing that we're doing with whole numbers, right? We have 4 different representations, so we're sort of limited into the types of numbers that we can use. So on the plus side, we can illustrate all kinds of things in base 10 using these same blocks as decimals. The downside is we start reassigning them different values than what we're used to using, and we have to remember what it is for each problem. So let's take a look at a couple of these, and then I'll have you fill in the rest of them. So look at the first one, 13 and 25 hundredths. So I said represent with base 10 blocks, define the smallest block first in each one. These are your tenths, these are your hundredths. So that means the smallest block here is going to be worth 1/100th. And then, you can write the rest of them, right? Then the longs will be worth a tenth, the flats will be worth a unit, and the cubes will be worth 10, but you don't have to. Once you define the smallest block, then I'll figure out the rest of it from there. So it's 5 little blocks, right? 5 hundredths. It's 2 tenths. It's 3 ones, or 3 units. And then it's 1 cube. Can I draw a cube on a whiteboard? Let's find out. Yeah, kind of. All right. So 1/10, 3 units, 2 tenths, and 5 hundredths. All right, look at the next one. It's 1.423. So 1 and 423 what? Tenths, hundreds, thousandths. So that means that in this problem, our smallest block is going to be worth 1/1000th. Otherwise, we're going to run out of blocks. So in this problem, our smallest block is worth 1/1000th. And then the flat is worth 1/100th. The rod is worth 1/100th. The flat is worth 1/10th. And the cube is worth 1. So we've got 3 thousandths. We've got 2 hundredths. We've got 4 tenths. And then we've got 1 unit. So my purple cube has a different value than my red cube does. Right? My purple cube is worth 1. The red cube in the problem above is worth 10. So it's not hard, right? It's very similar to what we were doing with the whole numbers in that everything along the lines is a power of 10 greater than the one before. So 10 of those little cubes makes a rod, 10 rods makes a flat, 10 flats makes a cube, except that now we have to define that smallest block in order for the problem to make sense. Right? Try those other two on your own, right? Draw them out. 31 and 27 hundredths and 1 and 85 hundredths. That last one, you actually have some choices because you only have 3 digits. You have 4 different types of blocks, so you can actually make that the hundredths for the last one the little block, or you can make the hundredths worth the rod, right? Either one will work. So in cases like that, there is more than one way to correctly represent it. All right, try those last two on your own, and then go back to Canvas for the rest of the activities.